Hello, CNBT 1311. Once again, we are back. Stone. Stone is an aggregate or a combination of minerals, each of which is composed of inorganic chemical substances. To qualify as a construction material, stone should have the following qualities. It's got to have strength, hardness, durability, workability, density, and appearance. And your mileage is going to vary. You're going to use stone as a structural wall. Um, you're going to need a good stonemason, somebody actually knows what they're doing. By the time that you pay for a natural stone wall that's structural, you probably could have got a reinforced CMU wall of some sort with a brick veneer than stone. I'm not opposed to stone. All right, I helped my uncle build some structural stone walls, and we had plenty of limestone around his place, and they were a double wide wall. So you have stone on one side, stone on the other, randomly laid with a good adhesive mortar, and we'd fill this cavity in with mortar and reinforcing steel, and then you'd have ties going across here just like you would with regular masonry. It would have been a whole lot easier to use CMUs because of the uniformity of your building material. It took a long time, but I mean, nobody was paying for our labor. So, but he wanted it, and we did it. And the next wall he did was out of concrete masonry units. So, all right. Workability for stone, it varies. Hardness, grain, texture. Can it be cut? Can it be squared? Can it be polished? Etc., etc. You can read through all this. And stone is classified according to the geological origin in the following: igneous rock, metamorphic rock, and sedimentary rock. All right. Igneous rock, such as granite, obsidian, malachite, is formed by the crystallization of molten magma. And metamorphic rock, such as marble and slate, has undergone a change in structure, texture, and composition due to natural agencies such as heat and pressure, especially when the rock becomes harder and more crystalline. And sedimentary rock is just that. It's formed from pressure under sediment. Limestone is a sedimentary rock. Limestone has calcium in it. Sandstone, shale. These are formed by the deposition of sediment during the glacial period. All right. All right. As a load-bearing wall material, stone is similar to modular units. Masonry, similar. Although some stone masonry is not necessarily uniform in size, it is laid up with mortar and used in compression. Almost all stone is adversely affected by sudden changes in temperature and should not be used where a high degree of fire resistance is required. Should not be used where a high degree of fire resistance is required. Again, I go back. The labor cost in putting a stone wall up, I will bet you, if you do a cost comparison, you'll find you could have gotten a good CMU reinforced wall with a brick veneer, if you didn't want to look at the ugly CMUs, a lot cheaper than you will stone. And a lot of stone is cut thin and just used as a veneer. But nonetheless, stone is used in construction in the following forms. We talked about rubble, riprap, filling gabions, okay? Slow down the water erosion. Dimension stone is quarried and squared. The stone that was used to build pyramids is considered dimension stone. Flagstone refers to flat stone slabs used for flooring and horizontal surfacing. And crushed stone is used as aggregate in concrete products, whether it's hard aggregate or limestone aggregate or a mix. All right, let's move on to wood. The American Institute of Timber Construction, AITC, was founded in 1952. It is the national trade association for the structural glued laminated timber glulam industry. All right, just like the American Plywood Association is, and they've changed their name. They used to be the American Plywood Association, and now they are. The APA was the American Plywood Association. Now it's the Engineered Wood Association. U.S. and Canadian manufacturers of structural engineered wood products, including plywood, oriented strand board, OSB, that's some nasty stuff, glue laminated timber, wood, I-joist, and structural composite lumber. You can go on their websites and get all the information that you could possibly want. As a construction material, wood has been used for centuries, just like stone. It's durable, lightweight, easy to work, it's renewable. You do timber harvesting and replant and maintain your timber form. You'll be ready to reharvest in 15 to 20 years. Tomball Gun Club, where I'm president of, we're a member of the American Texas Forestry Association, and we get an ag exemption for timber. And about every 15 to 20 years, we go in, we selectively harvest the mature trees. We hire a tree cutter to come in, and they come in and harvest it. And when he's done, we go back and replant seedlings, and then maintain that tree for them. Although it has become necessary to employ conservation measures to ensure a continuous supply of wood, is still used in construction in many and varied forms. What he's saying here is we no longer go in and just completely clear cut a mountain. Now, some of them scarps you see in the heavy timber parts of the world, United States, it looks like they came in and just clear cut everything. Well, they did. What you're not seeing is them going back and replanting what was cut, and then they'll let that grow and and then harvest it in 15 to 20 years. All right. There are two major classes of wood. There's softwood and hardwood. Softwood would be like pine, and hardwood would be like oak or maple, okay, or walnut. On that house I remodeled in Bryan in the 70s, that was built in around 1898 to 1900, somewhere in there. We used a lot of Texas walnut. We found some up in a sawmill in East Texas. We got the last of it. Had it specially cut, and we trucked it back down to the job site and used that as a fireplace wrapping along with some bird's eye maple. It turned out really, really pretty. He was an architecture professor at A&M, and took us about 2 years to finish that project. Part of that was because he used the wrong kind of foam. He used that formaldehyde-based foam. We had to let that outgas. All right, softwood is the wood from various predominantly evergreen and cone-bearing trees such as pine, fir, hemlock, spruce, and it's used for general construction. Your studs and joists and such as that in typical wood framing will be softwood. Hardwood is the wood from a broad-leafed flowering tree such as cherry, maple, oak, walnut, pecan. It's typically used for flooring, paneling, and furniture and interior trim. And most of the interior trim you're going to get now is pine. It's softwood. We're talking about some expensive interior trim, all right, here, but high-end architectural trim might be hardwood. You get it from a mill. The manner in which a tree grows affects its strength, its susceptibility to expansion and contraction, and its effectiveness as an insulator. Tree growth also affects how species of sawnwood may be joined to form the structure and enclosing of a building. You use hardwood for your furniture, like good maple or oak, or walnut, or cherry, and because it's hard, it's easy to cut. The joints are hard, so when you do a tenon cut, it's not susceptible to splitting like the softwoods are. All right. The manner in which a tree grows, we already said that. Okay. Wood does contract and expand. It warps. Grain direction is the major determining factor in the use of wood as a structural material. Tensile and compressive forces are best handled by wood in a direction parallel to the grain. So if the grain's running this way, you want the forces, compressive forces, parallel, not perpendicular. Okay. Typically, a given piece of wood will withstand a third more force in compression than in tension. That is a true statement. Allowable compressive force perpendicular to its grain is only 1/5 to 1/2 of the allowable compression force parallel to the grain. So if you're going to apply force perpendicular, then that's going to be 1/5 to 1/2 of what it'll take in compression. All right. Let's see. Shear strength of wood is greater across its grain than parallel to the grain, is therefore more susceptible to horizontal shear than to vertical shear. Okay. That's a true statement. All right. So if this is the grain of wood, the shear force is greater this way than in this way. If you're cutting parallel to the grain, we call that ripping on a table saw. If you're cutting across the grain, it's a cross cut. If you've ever done any carpentry work and you're ripping lumber, you'll know that it's this is a harder cut than a cross cut. All right, the manner in which lumber is cut from a log affects its strength as well as its appearance. Why? Because you're cutting in the grain, you're cutting across the grain, you're cutting diagonal to the grain. So we divide this into, we got plain sawing a square log into boards with evenly spaced parallel cuts results in a flat grain lumber that may have a variety of noticeable grain patterns, tends to twist and cup and wears unevenly, tends to have raised grain, and shrinks and swells less in thickness, but it shrinks and swells more in width. All right. So this is what's called plain sawing. You take a log and you come in here and just start cutting across the growth rings, because we know that they have a growth ring. These are growth rings here. This is the center, and these are growth rings. They radiate out, and that's why you have the varying appearances of the grain. All right. Now, in quarter sawing, you're trying to go in at right angles to the annular rings. So if these are the rings, you can see the rings here. All right. You're trying to come in at right angles. You want to come straight in and cut like that. So they call it quarter sawing because you're quartering out a piece of this pie. So if that's like a pizza, then you got 1, 2, 3, 4. They call that quarter sawing. You get more even grain patterns this way. It wears more evenly with less raised grain and warping. It shrinks and swells less in width, but it shrinks more and swells more in thickness. Where Plain sawing is just the opposite. It does more in width and less in thickness, right? Okay. Is less affected by surface checks and results in more, but this results in more waste in cutting and is more expensive. That's why quarter sawed lumber is more expensive um, when you buy it. To increase its strength, stability, and resistance to fungi, decay, and insects, wood is seasoned. In other words, you don't take a piece of green lumber that you've sawn and just start building with it. It's either air dried or kiln dried. Um, some fine furniture makers or fine, custom furniture carpenters, they have an opinion about whether they want kiln dried hardwood or air dried in a drying rack or shack outside. Um, so you want to dry it to reduce its moisture content. We talked about the warpage of the trailer deck I put on in another video. Um, so you air dry it or kiln dry it. And kiln drying is similar to the way bricks are kilned, put in the kiln, the wood stacked on a crib on a drying car, and the car is run into the kiln. And it's got very controlled conditions of heat and air circulation and humidity. And it is possible to completely seal a piece of wood to prevent changes in its moisture content. You can do that with epoxy coatings. Um, you can get a moisture meter and check the moisture content of your wood. Uh, but as the moisture content changes, either more or less, the wood's going to change. It'll change dimensions. It'll change shapes. It may cup on you. Okay, um, and so you have to come in here and you got to cut that cup out. I mean, cut that out. You run that through a shaper. I mean, a planer. Um, Below a moisture content of about 30%, wood expands and it absorbs moisture and shrinks as it loses moisture. Okay. This possibility of shrinkage and swelling must always be taken into account when detailing and constructing wood joints, both in small and large scale work. Now, when you're doing wood framing, nobody really cares about this. They don't take this into consideration. The wood is all kiln dried and it's stamped and it's bundled and put on a truck and sent out to your job site. Nobody waits several days for it to acclimate. Um, they just bust the bands and start grabbing the lumber and cutting it and framing. Because as it's going up, it will settle, and you're just going to have some dimensional changes, slightly, not to this extent. Okay. Um, Now you take a green sawed log. Some of these fine woodworking people, they'll get a log and they'll do their own milling. They got their own little sawmill, and then they'll take the wood that they cut out and they'll put it in an air drying shed and let it air dry for a couple of years. And it gets all warped out and shaped, and then they start working with it. Shrinkage. Tangential to the wood grain is usually twice as much as the radial shrinkage. Vertical grain lumber shrinks uniformly, while plain solid lumber near a log's perimeter will cup away from the center because of the thermal expansion of wood is generally much less than volume changes due to the changes in the moisture content. It's therefore a controlling factor. The moisture content is therefore the controlling factor. And you can go to Fine Woodworking or any of the other places that sell super duper fine woodworking tools, and you can get you a moisture meter and go start poking it into your wood and find out what the moisture content is. I think you're wasting your time, but I mean, unless you're into the zen of all this, cutting your own green lumber and then seizing it in a drying shed, just an air drying shed. Um, we're talking about the wood fiber saturation point. Okay, it's really what we're talking about. And the cell walls are fully saturated, but the cell cavities are void of water, ranging from a moisture content of 25 to 32% for the commonly used species. Further drying results in shrinkage and generally greater strength, stiffness, and density of the wood. So, the drier you can get it, the more dense it is, and the stronger it is. All right, here's some terms. Knots are hard nodes of wood that occur when branches, there's either be a branch growing into the tree before they cut it. Okay, he talks about the good, the bad, and the ugly knots. Shakes or separations. Um, this is a shake. It's a separation in the end grain. Okay, and it's along the grain of the wood. This is cross grain. This is parallel the grain. This is a cheek. Okay, or checks. Okay, checks. All right, we forgot pitch. Pitch pockets are well-defined openings between the annular rings of a softwood, containing or having, or once contained, solid or liquid pitch. Pitch is the resin. Okay, so this is not a tightly annular ring. For some reason, as this tree grew, it had an excess amount of resin in here, and it created a pitch pocket. Sometimes you'll get wood and that pitch will be leaking out. And it'll continue to leak as the wood ages, even after it's cut and kiln dried. Checks or lengthwise separations. Checks or lengthwise separations of wood across the annular ring. See, they're coming across. Here's the annular rings. These are growth rings. All right, and they go across. These are generally caused by uneven or rapid shrinkage during the seasoning process. If you reduce the content in the kiln too fastly, that moisture content, these things will start to appear. A wane is the presence of bark or absence of wood at a corner or along an edge of a piece. This is called a wane. You've probably seen at the lumber yard, or maybe you haven't, some of your dimension lumber will have like a piece of the wood removed, or they'll have a piece of bark in there. You know, of course, that way if you cut that thing close, like in this case, close to the edge of the bark of the tree. Because when they go to cut these, they debark them, but they don't get all the bark off sometimes. All right. Okay. Warping is usually caused by uneven drying. All right. During the seasoning process, or by a change in moisture content. I talked about that with the ground contact pressure treated wood that I use for my trailer deck. All right, this is a cup. It's like it makes a cup. Okay, this is a bow. So that long straight piece of wood is not straight. It has a bow in it. Okay, which means it's curving out. Okay, so that's a bow. A crook is a curvature along the edge of a wood piece. So if you look straight down from here to here, it's not flat. It's got a sag in it. Okay, that's a crook. And a twist is just that. That this end is at one plane, and then this end is at another plane. It's like a corkscrew. The thing's twisting. And it generally twists in opposite directions. Some of that deck lumber had a twist in it. Once it got here and got out in the sun, it twisted up. But I took the twist out of it with the jack system I put together before I welded the two toe plates at the end of the trailer. to hold all that down. All right, let's go back up here. Wood is wood is decay resistant when its moisture content is under 20%. If installed and maintained below this moisture content level, wood will usually not rot. Now, dry rot is not just dry rot, okay? There has to be some element of moisture. They call it dry rot because it's not submerged in water. But in the space in which that wood is encapsulated, there's moisture in there. We talked about moisture in walls to get an air space to get the moisture out. But if you can keep everything below 20% moisture content, it will usually not rot. All right, that don't mean it won't, but it usually will not. There are some species that are naturally resistant to decay. And the decay is usually fungi. It's fungal, eating the wood fibers, the cellulose in the wood itself. These include redwood, cedar, bald cypress, black locust, black walnut. Insect-resistant species include redwood, eastern red cedar, and bald cypress. Insects don't like them. It's because of the oil in the wood. The same way about the fungus in redwood or cedar or bald cypress. The consistency of the resin in the tree, the wood, the fungi can't grow. All right. Now you can preserve treatments that are available for further protect wood from decay and insect attack. Let's see where are we at here. Let me look at the 5th edition, because he's got something here in the what is this? This is 12. Here we go. Creosote, talks about creosote. Somewhere in here, I thought he listed, yeah, here it is, pentachlorophyll. Yeah, all right, pentachlorophyll. It's in both of them, 4th edition and 5th. All right. All right. Of these pressure treatments, the most is most effective, especially when the wood is in contact with the ground. There are 3 types of preservatives. There's waterborne, could be a CCA salt. Most of your treated lumber that you get these days is a waterborne preservative. It leaves the wood clean, odorless, and it's readily paintable once the preservatives, the moisture leaches out. You'll notice that your treated lumber is wetter to the touch when you buy it. But these preservatives don't leach out like the oil-based stuff, like creosote. All right. AWP is the American Wood Preservatives Bureau. LP2 is or LP22 is for ground contact. Your preservative lumber that you get will have a tag stapled to the end of the board, sometimes both ends, and it'll tell you what it's rated for, whether it's exterior exposed or ground contact. When this first stuff came out, it was a CCA salt that was water bathed into the wood. So now we just increased the water content. So if you're going to use this, like for the decking, I let that stuff sit out for a couple of weeks before I tried to use it. I just laid it out on the trailer frame and let it sit out there in the sun and cook and leach out what moisture content it had leached out in it, and figured out where it was going to twist, and then laid it down and started attaching it to the trailer. All right. Oil-borne preservatives. Oil-borne preservatives. And this is where the EPA gets kind of freaked out. May color the wood, but treated wood is paintable. Now, pentachlorophenol is highly toxic. This is pentatreated. They used to sell this for ranches and farms a lot. It was called penta. You know, I just got from the first part of it. Pentachlorophenol is very highly toxic. And when you're cutting this, like you're going to make a corral, I use this for that guy's fence on that house in the back. He wanted like a corral-like looking thing, and you had to be careful of the sawdust. So when you're cutting it with a saw, you wear a mask. So, because this stuff is highly toxic. Let's see. Again, the American Wood Preservatives Bureau labels pentatreated as LP33 for ground contact, and they've got. You can go out there to the bureau and look at all their stuff. Creosote. I don't know what creosote. Railroad ties are creosoted. Wood railroad ties. It's that black oily surface. The odor remains for a long period. It's used especially in marine and saltwater installations and transmission poles. All right, your electric poles are the black ones. They're creosoted. A lot of utility companies are switching over to non-wood poles and or regular CCA salt, waterborne preservatives. Creosote is toxic, and you got to be careful with it. And when it gets hot during the summer, that oil will leach out of that pole, creosote pole, forever. The creosoting is put in by pressure in a heated kiln-like thing. There's a big creosote operation up in Somerville, Texas, that they specialize in railroad ties. They make railroad ties. All right. American Wood Preservers Association lists creosote as LP5, LP55 for ground contact. All right. Now the defects that we just went through over here, they affect your grading, appearance, and use of wood. They may also affect the wood strength. You got a bunch of these in here, a bunch of knots. Try driving a nail through a knot. Sometimes these knots will fall out, leave you a big hole in your lumber, and they will affect the wood strength depending on the number, size, and location. The defects include the natural characteristics of wood, such as knots, shakes, pitch pockets, as well as the effects of manufacturing, such as checks and warping. That's probably more than you ever want to know. All right, what's on this page? All right. Because of the diversity of its applications and its use for remanufacturing purposes, hardwood is graded according to the amount of clear, unusable lumber in a piece that may be cut into smaller pieces of a certain grade and size. Softwood is classified in the following manner: yard lumber, factory and shop lumber, softwood, okay, all right, yard lumber, factory and shop lumber, and yard lumber, boards less than 2 inches thick, and dimension lumber, that's 2 by 4, 2 inches to 4 inches, structural lumber, dimension lumber, timbers, all right, and then there's subcategory under dimension lumber. You got joist and planks, you got light framing, joist and planks, light framing, and then decking. And then structural lumber is beams and stringers, posts and timbers. We're not going to belabor all this. You know where to find it if you get asked. The lumber is specified by species and grade. Lumber is specified by species and grade. Okay? Each piece of lumber is graded for structural strength and appearance. It may be graded visually by a trained inspector or, or by a machine that fixes a test specimen. In other words, they take a test specimen and they compress it just like concrete. Measures the resistance to bending, calculates its homogeneous elasticity, etc., etc., etc. All right. Each piece of lumber has a grade mark indicating the assigned stress grade. It'll be ink stamped or pressed like this. So you'll have a stress grade, a design value. It has a base value, and okay, and then the base values are adjusted for size and other things. All right, such as moisture content. Again, we go back to moisture content. All right, so any of the allowable unit stresses for bending and compression, perpendicular, parallel grain. This goes back to your base value. Horizontal shear and corresponding modulus elasticity. Now, you don't care about that. But with the design value equals the base value times any adjustment that happened, okay? So this says it's machine rated, and it's hemlock fir or hemp fir, all right? And it's dry, there's moisture content. All right. Lumber is measured in board feet. 1 board foot is equal to the volume of a piece whose nominal dimensions are 12 inches square and 1 inch thick. All right. Now, normally you will not be buying lumber for a framing job and you're going to order so many board feet. You're going to order a bundle of pre-cut studs. All right. And they're not 8 foot long. They're pre-cut if it's stud lumber. And they're graded, and they'll take into account the thickness of the base plate, which is 1.5 inches, and then the top seal plate, or the top plate, which is another 1.5 inches, or the double plate. So they'll be less than 8 feet. Now, if you just go buy a normal 2x4 that's 8 foot long, then if you're going to use it for framing, you're going to have to cut it. All right. Dress size. Your nominal dimensions are the dimensions of a piece of lumber before drying and surfacing. Like a 2x4 is a nominal. But the dress size is the actual dimension of a piece of lumber after seasoning and surfacing. Okay? All right, for dress size, you subtract 1/4 inch from nominal dimensions up to 2 inches. You subtract 1/2 inch from the nominal dimensions of 2 inches to 6 inches, and subtract 3/4 from nominal dimensions greater than 6 inches. Lumber is generally available in lengths from 6 feet to 24 feet in multiples of 2 foot. Your mileage in here, these dress sizes are going to vary. You check your supplier. If you go out to Home Depot or Lowe's and you look for a 2x4, let's just say you want a certain grade of 2x4. That 2x4 is the nominal dimension. You go look at the specs of what they're selling, they'll tell you the exact dimension, the actual dimension of that piece of lumber. And don't be surprised if it varies from this, okay? Do not be surprised if it varies from this. You go check your supplier. You check your supplier. Do not assume. All right, wood panel products. Wood panel, this covers plywood, OSB, MDF, you name it, okay? Span rating specifies the maximum recommended center-to-center spacing in inches of the supports for a structural wood panel spanning in its long dimension across 3 or more supports. So, what does this mean? 3216. What does that mean? Okay, well, that's 32 inches for roof sheeting, for roof decking, and 16 inches for flooring. All right. You check your panel rating. This will be a stamp on it. The APA rated sheeting and 15 32nd inch. Okay. So you go buy a half-inch sheet of plywood. Don't expect it to be half inches. It'll tell you exactly what the thickness is. See, that's what is that? That's a 1/16 of an inch, less than a half inch. So when you go ready to make a piece of furniture out of plywood, you got to take that into account. All right. Which is a pain when you're doing edging, because if you're using 3/4 inch plywood, your rounded molded come in at 3/4 of an inch. So you got to cut the molding. You got to run it through the table saw. All right. Now, wood panel products are less acceptable to shrinkage and swelling, and they require less labor to install. They make more efficient use of wood resources than solid wood products. The following are the major types of wood panel products. You got plywood. It's made by bonding veneers together under heat and pressure, usually with the grain of adjacent plies at right angles to one another. Each one of these plies are 90 degrees to one another, so the grains run in one direction and this grain's running in another direction. Then we switch back and then we change directions, and then the final veneer is put on there. All right. Now, are less susceptible. That doesn't mean they won't. I've got some plywood that I used for some doors, and they were fine until about 2 years into their life, and they started twisting. Why? Who knows? Most likely it's the moisture content. Grade stamp is a trademark of the American Plywood Association. It's stamped on the back of structural wood panel product to identify the panel grade and thickness, span rating, exposure durability, and the National Research Board report number. Okay? National Research Board report number. You go out to the APA website, not the American Psychiatrist Association, but the American Plywood Association, which is now the Engineered Wood Association, and they have all kinds of manuals and recommendations on how to use this stuff. High density overlay, HDO, is an exterior wood paneling having a resin fiber overlay on both sides, providing a smooth, hard abrasion resistant. It's used for concrete forms and cabinets and countertops. Medium density overlay is an exterior wood paneling having a phenolic or melamine resin overlay on one or both sides, providing a smooth base for painting. Specialty panel refers to any various wood panel product as grooved or rough sawn. Like T111 would be a specialty panel. T111, remember that? For the wall coverings. All right. The veneer grades define the appearance of a veneer in terms of growth characteristics. All right. So you have engineered grades, relatively high shear strength for loads, perpendicular, used for subflooring or in the fabrication of box beams and stress skin panels. Now, on the outside of these plywoods, you've got your veneer grades. What is the grade of the veneer? It's the appearance of the veneer in terms of growth characteristics. N grade is a smooth, softwood veneer of all heartwood or all sapwood. It's free from open defects with only a few well-matched repairs. Well, Your mileage is going to vary with that. A grade is a smooth, paintable softwood veneer with limited number of neatly made repairs. B grade is softwood veneer having a solid surface with circular repair plugs. Tight knots and minor splits are permitted. We're going down the ladder now. C grade, softwood veneer having tight knots and knot holes of limited size, synthetic or wood repairs, and discoloration and sanding defects that do not impair the strength of the panel. C plug grade is an improved C grade of softwood veneer having smaller knots and knot holes, some broken grain, and synthetic repairs. And D grade is a softwood veneer having large knots and knot holes, pitch pockets, and tapering splits. All right. Now, then you have furniture grade, all right, which is not mentioned here, all right. And then marine grade. I've seen some N grade that was supposed to be super duper, and it had more than a few well-matched repairs. Your mileage will vary. So, particle board is a non-veneered wood panel product made of bonding small wood particles. They take the sawdust left over and mix it with resin and pressure treat a board. That's particle board. Use a core material for decorative panels and cabinet work as an underlayment for floors. It's crap. It gets wet, it blows apart, and its strength is not good at all. Oriented strand board is a non-veneered wood panel product commonly used for sheathing and as subflooring. It's made of bonding layers of long, thin wood strands under heat and pressure using a waterproof adhesive. The surface strands are aligned parallel to the long axis of the panel, making the panel stronger along its length. Stay away from particle board. Oriented strand, OSB. This stuff gets wet over a long period of time, it'll come apart. I don't care what they say about the glue. All right. I replaced a bunch of OSB when I redid my roof, and replaced it with plywood. Wafer board is a non-veneered panel product. All right. It's composed of large, thin wood flakes. Okay. And it's composed of large, thin wood flakes bonded under heat and pressure with a waterproof adhesive. The planes of the wafers are generally oriented parallel to the plane of the panel, but their grain directions are random, making the panel approximately equal in strength and stiffness in all directions in the plane of the panel. Your mileage is going to vary with wafer board and OSB as far as what it can actually support. I would stay away from this. If you can afford to go with plywood, an APA grade of plywood, do that. I'm telling you. And then there's MDF, which is almost like particle board, but its dimensional stability is not that great. And it's a glued product together under pressure and heat, and it does not like water. Water likes it, but it does not like water. All right, let's get into plastics. Where are we at on time? We're at 49 minutes. Let's go ahead and make another video. This is going to be 12:4. Yeah, 12:4.